Hi Wing, this is how to do the thing. And so I think like the part we're stuck on is like here, right? Where you substitute y. Because y here originally is equal to this thing. And so when you get to here, this y gets substituted with the inverse sine 8x plus 1. And this is the confusing part, right? It's like what the heck's happening over here? So what's happening is that normally when you do a sine, right, you're inputting a radian, like a pi over, say, 6, or even a degree, right? And you're returning a ratio of opposite over hypotenuse. And say, for example, this one, right? The sine of pi over 6 would return like 1 over 2, right? Or if you see it in the triangle, it'll be like, this is 30 degrees, and then this in the unit circle is 1, and this is 0.5, correct? So, and then this is, again, this is like 0.5 over 1, because like this is like the same, right? Ratio. So it returns you're given a degree and you put a ratio of the opposite, which is here, and then the hypotenuse, which is here. Okay, so, and then what's happening with the inverse sine is you're putting in, this is accepting the ratio, and you're getting back the degree or the radian, right? So, for example, if I put in this ratio that I just got from the output of earlier, it's like 0.5 over 1, or 1/2, then I say, okay, in that triangle, if I have a triangle where this is the output, 0.5, this is the degree we're taking, like 0.5, and then this is the hypotenuse, then, the degree must be 30, or the degree must be pi over 6, okay? So here, the input is, the sine is the radian, and then the output is the ratio of the triangle. And here the input is the ratio of the triangle, and the output is the radian, or the degree. Okay, so that's important to understand, because like over here is it's saying that, okay, this is an inverse sine function, therefore I am taking as my input the ratio of the triangle. And implicitly, there's a 1 here, because the ratio here is 8x plus 1, which is the opposite. If we form this triangle, or actually right here. So this is the opposite, right? And then implicitly, because this is an implicit 1, this is the hypotenuse of that triangle, like an imaginary triangle, because like all inverse sine functions are referring to triangles, right? Or the unit circle triangle. So, okay, well, I know that this is going to return a degree, right? Or a theta. So the theta, we form this triangle, and this is the theta we're trying to return. So this negative inverse sine is trying to return whatever this theta is, right? And so this is really going to be like, oh, now this is going to be cosine of that theta. Because this thing returned me a theta of a unit circle, and now that theta is being used as the input of a normal cosine thing, right? Okay, and then what's happening is, like, because this cosine theta gets transformed into this funky thing right here. So where did this funky thing come from? Okay, so what's happening? Let's go back to this unit circle. In this unit circle, I have this as the opposite, this is the hypotenuse, and this is the theta, right? And so I know that let's see, cosine squared plus sine squared equals 1 squared in the unit circle. Why? Because it's a Pythagorean theorem, right? With all of the denominators being 1 in the unit circle, or standardized to 1, right? So, for example, this will be this question mark. Let's say this is the cosine over 1 squared. So question mark squared over 1 squared, and then plus the sine squared, which is 8x plus 1 squared over 1 squared, because this is sine, right? Like opposite over hypotenuse, and then this is 1 squared over 1 squared. Or sorry, this is just 1 squared. Okay, right. So, you know, these are, now this is just 1, right? So I don't even need to think about this because these are just 1. And so I can form the identity as this, right? And then I can do some manipulation, right? Because this is the cosine, right? So this is be like, I rearrange it. So like, oh, okay, I put this over here, I swap these, and I put this over here, and then I negate the signs over here. So this is the cosine theta I was talking about earlier, and then blah blah blah. And because it's like squared, I have to like take the square root, right? And so this is going to be, this is actually saying cosine theta is equal to all of this stuff, right? Okay, and so because I know in this triangle cosine theta is equal to this stuff, and this gets turned into, this whole thing gets turned into a cosine theta, because again, like this thing is saying, oh, for this is like inverse sine, oh, we're going to use this triangle, and I'm going to return you the cosine, I'm going to give you cosine this theta of that triangle. And so, and then the cosine theta of that triangle is equal to this, and if I can replace cosine theta with this, and then you do all the, I'm sure like you know all the like the algebra stuff, right? Blah 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 blah. But that's the real thing. That's the real confusing part, because like you're trying to understand the relationship, or why do we generate this triangle using just this like input, right? This weird input, and it's because this, whenever you're using an inverse sine, you're generating a triangle with these ratios, and then you're returning this theta right here. And this theta, when you if you put it in this form of cosine theta, you can see where that thing came from. Okay, anyways, that was a long explanation, but that's how you do it.